Okay, so now we're going to work on solving logarithmic equations. So logarithmic equations are going to be ones such as log base 2 of x equals 4. So we just have our x is going to be here in the exponent. Log x plus 3 equals 1 are called logarithmic expressions. One of the best ways to solve these is first, if it's necessary, we try to obtain a single logarithmic expression. So like this one here with log 2x equals 4, we wouldn't have to do any extra work for. We would just have to, we wouldn't have to combine it into a single logarithm. But log x plus log x plus 3, that one we'd have to try to combine first. But once we combine to a single logarithmic expression on one side, then we are going to write an equivalent exponential equation. Because as a reminder, this here out here is going to be a power. So if I had log base 3 of x equals -2, what I could rewrite that as 3 is my base, this is my power, so this is 3 to the -2 would equal x. Well, 3 to the -2 is just 1 over 3 squared, which is just 1/9. So my solution here with the x would have to be 1/9. In this case, we are going to have to try to combine everything into one logarithm first. So we have a base 10 log, a base 10 log, and they're added together. So now we know this can be rewritten as log of x times x plus 3. Because this and this would have to be made into a product. This is going to equal 1. So I have log of x squared plus 3x will equal 1. So remember, this is a common log, so it's a base 10. So that means I have a base 10. This out here is my power, so 10 to the power of 1 should equal x squared plus 3x. So what you would notice is here we have a polynomial function. So if I just solve this, so I'm going to have the 2x plus 3x. If I subtract 10 from both sides, 10 will be over here. So I have to rewrite it so it's set equal to 0. And then I just have to factor. So x plus 5, x minus 2. If we add these together, that's going to give us a plus 3. If we multiply, it's going to give us a -10. So that's the factored form of x squared plus 3x minus 10. Means my two solutions would be x is equal to -5 or it is equal to 2. So number 15, we have a couple different logarithmic expressions here. So try to, like I said, combine anything with a log to one side into a single logarithm, and then from there, try to solve it. So if we were to do A, so I'm going to get rid of B here for just a little bit. First thing we need to do is, like I said, we have the same base. I can combine these into log base 3 of x minus 2 times x plus 1 because of the addition. So I need a power of 3. So we got 3 is my base. We need, and it's going to have the power of 2. So I said that a little awkward. And what would be left over is this part here. So we would have x plus 2 times x minus 2 plus times x plus 1. So this is just 9. And if we FOIL the other side, it's just going to be x squared minus x minus 2. Subtract 9 from both sides. We're just going to rewrite like this, but x squared minus x minus 11 equals 0. So we have a quadratic to solve. We can't solve this one with factoring, but we have AC method. or not AC method, I apologize for that. We have quadratic formula. So A is 1, B is -1, C is -11. So my solutions would be negative b plus or minus square root of b squared minus 4ac divided by 2a. So we will have a -1, so +1, plus or minus the square root of 1 squared, so 1, minus 4 times a times c, so plus 44. Divided by 2a, so that would just be 2. So what we have as answers is it's 1 plus or minus the square root of 45 over 2. So you got to be careful with logarithms because remember, we cannot, what's in here has to stay positive. So we just need to make sure that both of these answers work. So if we did this and we had the -1 plus 45 divided by 2 minus 1, or sorry, minus 2 as we have up here, that's still positive. A second, I gotta fix that one, though my numbers didn't catch right. Okay, so like I said, we just have to make sure that both of these answers work as solutions. So we would have to plug these back in. So we see here that if we try both answers, so I had to write this converted, but remember we have log of x minus 2, log base 3, and then log base 3 of x plus 1 equals 2. And we said that our answer was going to be 1 plus or minus the square root of 45 over 2. So if we try 1 minus 45 over 2, we see we get undefined. The problem is you see right here and right here, I'm doing a log of a negative number. Like I said, just to recall that we had this restriction that we had to make sure that x stayed positive. So in this case, x is not positive. So one of the answers I have to throw out would be this one right here. So like I said, we have 1 or 2 answers, and we just discovered that one of them does not work. So we're going to change this to the plus. When I have the plus, we see this equals 2, like it should. So this is our only solution. Sometimes you have to be careful, especially when you're looking at logarithms, to check those answers to make sure that they're actually working for us. Apologize. Let me record that one more time quickly. It wasn't showing the correct screen. So like I was saying, we have log of log base 3 of x minus 2 plus log base 3 of x plus 1, and that was supposed to equal 2. My two solutions were 1 minus square root of 45 over 2 or 1 plus square root of 45 over 2. Sorry about that. It was showing the wrong screen when I was doing that. So what we have here is that if I do the 1 minus square root of 45 over 2 and we plug that in, so I just had to do the change of base formula on this, but it's the same thing. What we see is that here we're trying to do a log of a negative, and here we're trying to do a log of a negative number. And we can't do logarithms of negative numbers. One of our restrictions was that we had to make sure that x stays positive. Because, like I said, we were looking at the range of the exponential function is that it can never be negative. Therefore, when we're looking at the logarithm, the main is it can never be negative. But if I change this to a positive, we see here that it does actually give me a 2. So what we have is that we have one failed answer. This can't work. this one can't. So always check those answers. All right, so looking at B, we're going to rewrite this so it's actually, there we go. We can there's a couple ways we can actually solve this, but kind of following our rules is that we said we want to combine all our logarithms to a single logarithm. So I'm going to actually subtract the ln of x, or natural log of x. So what this is going to do is that it's going to be all on this side, and then we're divide, and that's going to equal 0. So if we combine our logarithms, we have natural log. So 4x plus 6, that would come from the positive logarithm, that's on top. Negative, so x plus 5 is going to be on the bottom, and this is also negative, so the x is in the denominator as well. And this is all equal to 0. So this is the natural log. So what we have here is e to the 0, because it's a base e. This is my exponent, has to be equal to 4x plus 6. And then we just go, this is just x squared plus 5x. Which then means that what we have is 4x plus 6 over x squared plus 5x is equal to 0. Or sorry, to 1. So this is what we have to solve. So one of the things we're going to check here is that some of these answers may not work in the domain once I do this. So we're going to have to check our answers again. But I can multiply both sides by x squared plus 5x, meaning that I will have 4x plus 6. And when I multiply that to that 1, we are just going to have my x squared plus 5x. So I'm just changing the order here for a second. We have a polynomial, so if I solve it so it's equal to 0, we're going to have x squared plus x plus 6 equals 0. If I factor this, I'm going to get x, oops, negative 6. I was going to say one of those is wrong. Negative 6 equals 0. If I factor this, I'm going to get x minus 2 times x plus 3 equals 0. Meaning my two possible solutions is x is going to be equal to negative 2, negative 3, or x is going to be equal to positive 2. Okay, so first things first, those answers work here in the denominator, so that's not a problem. What we have to consider is here, which ones are going to work for us. So you might already notice that the negative 3 looks like it's going to be a problem, because that means I'd have to do a natural log of a negative number. But like I said, we're just going to test these both and see that they work. So what we see here is that I'm going to split this because I got two logarithmic functions. So the last one side was like equal to just 2, so that was a little easier. But here I'm going to put in this and this, and I'm just replacing x with negative 3. As we see in both cases, it's going to be undefined because I'm doing a natural log of a negative here. Right here, I'd have negative 12 plus 6, so this would be negative 6. This would also be a negative number. So both of these are undefined. Now, if I went back and I plugged in my 2, okay, there we go. I did fix some. I accidentally put a plus here instead of a negative, and I'm going, this worked a second ago. Okay, so when we put that in there, right, we see that this side equals this side. Also, if you just need extra proof, if I did these in Desmos, so the one side and the other side, as we see they cross here when x is 2. So that twice showing you that it is a solution. So in that case, our solution is going to be just x is equal to 2.